and you've probably seen this before, but right up here on the smart board, there's a power button, and you guys may or may not have noticed what a power button looks like, right? But it looks like this. Almost, it's kind of a. Let's see if I can draw. If it'll let me draw. Okay. Oh, come on. Why not? Here we go. I calibrated it the last time I was in here. So is it still going here? Okay, good. We're going. All right. So anyway, let's see if maybe I can do it. Probably can't now, right? Heaven forbid I assume the technology would work, right? Okay, forget it. Agree. uh, anyway, now I'm stuck on my cord on the chair here. All right. So anyway, the people listening at home won't be able to see this because they don't have it. But a power button basically looks like this is amazing, right? Looks like this. You guys have probably all seen that before, right? And that symbol represents 0 and 1. It represents binary. Did you guys know that? Everybody know that that's what the power symbol represents? And that's because in sort of electrical engineering and circuit design, all computer stuff is done in binary, zeros and ones. And so you basically got two things that you use here. You use a 1 or a 0, and this can represent lots of different things. Okay, and that's what we're going to work with today, just essentially ones and zeros. All right, so 1 and 0, truly it means 1 means on and 0 means off. Or in electrical engineering, we could say 1 is a current, there is a current flowing, and the 0 means no current, okay? So you could say that's actually the voltage or the amperage is 0 in that case, okay? We could think of it as 1 being yes and 0 being no. We could think of it as 1 being positive and 0 being negative or something of that nature, okay? That's the basics of a sort of a Boolean logic. Okay, so Boolean logic is named after an English mathematician named George Boole, who came up with Boolean logic. Okay, and everything in the digital age is based on this. Okay, it's based on this ones and zeros. Okay, what's nice about it is things are black and white, right? So it's this way or it's that way. There's sort of no iffy in between. So we're going to play with some Boolean stuff today. And if you ever, want to learn to design your own digital circuits, you can do that. You can do that. It's actually kind of fun. So in your computer right now, everything is stored this way. Memory is stored this way as a series of on and offs. CDs have little etchings in them that will either reflect a beam of light back to a mirror or it won't reflect it. Reflection means 1, no reflection means 0, right? And so everything is kind of based on this. So that's what we're going to play with today, okay? Oh, right. Yeah, yeah, because like on the side, I could see that. I could see that. So it's really interesting because when I was younger, that was not the symbol for a power button. No, almost nothing had a power button with that symbol on it. But over time, it sort of became that representation of 1 and 0, on and off. That's how you turn the thing on and off, right? All right, so we're going to start out, guys, with some bool types. So I'm going to put this in here. All right. So I told you there was another type of information out there, or another class, and that's the bool. And so I'm going to show you how this works. It's pretty easy to show. So stick with me here. So we're just going to print the following. This may seem a little bit elementary, but we're going to say 1 equals 1. Now notice I put the double equal sign in there, okay, because we're not assigning a variable. I'm just saying 1 is equal to 1. Since we use the equal sign for assigning variables, we have to represent equal some other way. Okay, so I'm going to close that parenthesis. What I would like for you guys to do is go ahead and run this program. You can call it Introduction to Boolean if you want to. That's what I called it. And watch what happens when we run that. What does it say? True. 1 does equal 1, right? Excellent, excellent. It says true. All right, so that's good. Now, do you guys feel pretty good about yourself? Could you try it with something else? Let's try, what if I say print x equals x? What do you think it'll do? Let's just run it and see. Oh, it doesn't like that because we didn't define x, right? But what if maybe up here I said x equals 3, okay? Now let's do it. Yep, true, true. True, true. It's good. We like it. All right. What if I do something, guys, that isn't actually equal, but I try to tell it that it is? So let's say print 1 equals 2. Okay? 1 equals 2. Run that, and it says false. Okay. And that's all the answers we can possibly have right there, guys. We don't have a maybe. We don't have a you're an idiot. We don't have possibly. My sources say no. There's no magic 8 ball here, right? Try again later. It just says true or false. All right. Now, I'm going to show you guys that this is neither a string nor an integer or a float. Okay, so we're going to prove that right now. So here's what I want you to do. Actually, I'm just going to do one more thing. What happens if you say print true? What do you think happens? Okay, and print false. Notice they are capitalized, and notice on your screen that they change colors when I type those in. If I run that, I'm going to get just true and false again. Okay, so I'm putting in some Boolean information here. All right, I'm going to put a little space in here just to keep things tidy. All right, whoops, I used a capital P and it did not like that because that's not the print function. All right, now I'm going to do this. I'm going to say, remember how, this was way back when, but when we put in some information, we could use the type function to tell us what type of, like, you know, whether that was an integer or a float or something. We can do that here too. If I say type true, okay, and I could do that for false as well, print type false, all right, and run that, I am going to get the following. It's giving me right over here, if you take a look at my shell, it says class bool. Class bool. All right. So what it is saying is that that is a Boolean expression. It's not an integer, right? It's not a string. It's not a float. It's a bool. It's a true or a false. It's a 1 or a 0. It's an on or an off. It's a yes or a no. It's a cat or a dog, right? It's a peanut butter or a jelly. It's a do or a don't. A plum or a bum. Okay. All right. I got it. All right. All right. I'm going to put some spaces in there and we're going to go on. All right. So there you go, guys. We got the basis of what a bool is. Okay. Now let's play around with some operators here. And I have already looked around at your guys' work and I know you already know some of these. Okay. All right. So um, one of my favorite things when I was in grade school is I learned the signs for greater than and less than. And the way my teacher taught it to me is that the greater than and less than symbol is a little alligator. And the alligator is always hungry, so it's always going to eat the bigger number, right? Yeah, well, it just like I never even thought of it as greater than or less than. I just always knew the alligator wanted to eat the bigger number, right? And so I didn't really think too much about it. I was just like, oh, well, just make sure that alligator is going to eat the biggest number, right? So we're going to play around with those today. Those are some Boolean operators here. So here we go. I'm going to print things out in order to sort of not just see in our output and our shell just a bunch of trues and falses and things like that. So I'm going to do the following. I'm going to say 2 plus 3 equals 5. Okay? And I'm going to end my quotes there. That's a string, right? 2 plus 3 equals 5. And what I'm going to do now is I'm going to actually say whether or not that's true or false. And I can do it the following way. I can say 2 plus 3 equal 5 and end my parentheses there. Okay? So now what this will do, of course, it'll print out 2 plus 3 equals 5, and then afterwards it's going to tell me true or false, right? Is that true or is that false? So if I run that, here's what I should see. There it is. 2 plus 3 equals 5. True. Okay? So that's just your equals. But I did want to show you that in your sort of Boolean expressions there, I don't have to say 5 equals 5, right? I can put 2 plus 3 in there. I could say 2.5 times 2 and equals 5, equals 5, and it's going to still be true, okay? So all that's going on in this Boolean stuff is it's truly assessing a condition. It's going to be one way or it's going to be the other. It's going to be true or it's going to be false, okay? I can try other things as well. So I could say, for example, print 4 is greater than 3, okay? And then for my Boolean check here, I can say 4 right? The alligator eats the 4, 3, 4 greater than 3. Finish that off. I can run that. And I should see 2 plus 3 equals 5, true. 4 is greater than 3, true. Okay? And you can mess around here and change your numbers up if you want to. I can say the same thing as, less than, right? Let's say 5 is less than 8. I want to check that. I just say 5 less than 8 for my bool. Okay? So really what I'm trying to show you are these little bits after the text here. I'm just putting the text in there so we can follow along a little easier in the shell, right? 2 plus 3 equals 5, right? We can do less than and equal to. We can do does not equal, okay? And I'm going to show you how to do nots in a couple of different ways, okay? One in are just sort of our Boolean operator, and the other I'm going to show you where when we are working with the logic, we can actually type the word not. But let's do something else first. All right, so let's do 2 does not equal 3, okay? And the way we do a not, and some of you probably already know this, is we put an exclamation in front of the equal, okay? So I say 2 does not equal 3 right there. I'll move this up for you. Let me hit enter a few times. All right, so I said 2 does not equal 3. This is 2 does not equal 3. If those two are not equal, it will tell me true, right? Because that's what I'm saying. 2 does not equal 3. Is that true? Yes, that's true. So it'll actually do that. You can run these just to double check them over here. I'm trying to write all true expressions here, so each one should come back being true. Okay. You could do something like, let's say 5 is greater than or equal to 1. Okay. And that's going to be pretty simple. We're going to say 5. We're going to use the greater than symbol. We're going to say equals, and I'm going to put a 1 on there. Okay. So we can do greater than or equal to if we need to. And the other one then we can do is less than or equal to, right? So if I say 4, whoops, 4 is less than or equal to 4, just to prove it there, we can run those and they should all come back as being true expressions, right? And that's what we get over here when we run all of that. All right, so those are just your kind of Boolean operators here. The symbols you need to know. The double equals, greater than, less than, the not, which is the exclamation, equals, and then you can use the greater than or less than in front of your equal sign to make greater than or equal to, less than or equal to. Okay, so now let's put these into practice with a little bit of Boolean logic. And there's 3 statements you need to know for Boolean logic. I'm actually going to put them here in a hashtag form. I'm going to say basic Boolean logic. Those 3 statements you need are and, or, and not. Okay? And, or, and not are the statements that we can use. When you guys type and, or not outside of quotation marks, you're going to see that they're going to change color in your idle editor because they actually have a special feature or function to them. Okay, so you can never name, just so you know, you can't name like your variables and or not. Python won't let you do it. It won't recognize it. Those are sort of a set of words that are set off to be used for other things. All right, so let's do a little input so we can play around here. Okay, so I'm going to say x equals, and I'm going to instruct it to pick a number between 1 and 10. Okay, I want to make sure that's an integer instead of a string, so I'm going to start out with int. I'm going to do input, and then I'm going to say pick a number between 1 and 10, and make sure you do your double parentheses there at the end so it knows to do something else. All right, now what I'm asking it to do is to pick a number, and all I really want this program to do is to be able to tell you whether you actually picked a number between 1 and 10, okay? And it's pretty simple to do. In fact, I don't need to do anything other than a print command. So I'm going to say print, okay? And the input we assign to variable x. So I'm going to say if x is greater than or equal to 1, and notice that the and changes colors. x is less than or equal to 10. Okay? And that's all I'm going to put. Okay? So what I've done here, guys, is I've made some logic. It's going to actually be doing two things. In order for this Boolean expression to be true or false, it's going to have to evaluate two things. It has to be x greater than or equal to 1, and at the same time, it has to be less than or equal to 10. So if I put the number 47 in there, it should tell me that's false because I didn't actually do that, right? So let's go ahead and try it out, guys. 45. Okay. All right. So pick a number that isn't between 1 and 10. Okay. I'm going to put 19 in there. And watch what happens. False. False. You didn't do it right, you moron, right? So that's what the computer's telling me. Now, you might want to run it again just to make sure. Pick a number that is between 1 and 10. I'm going to pick the number 8. And yeah, true. Okay. So it's very important, right, guys, that you recognize that. And in there, it's going to be evaluating both of those Boolean expressions. It's going to have to fit this and that in order to be true. Okay. You can't have just one of them or the other. If you would like one or the other, you're not going to use an and. Instead, you're going to use an or. Okay. So let's do one of those. So let's make a new variable y, and let's make this an integer and an input. And I'm going to just tell it to do something very specific, right? I'm going to say the following. Type the number 4 or 8, okay? I'm commanding the user. You will type the number 4 or 8, okay? All right. All right. So now let's do an or logic here, okay? And note I'm using y here. So what I'm going to say is y equals 4. Okay, they better have typed y equals 4, or I accept y equals 8 as well. Okay, notice I'm doing this with no if statements whatsoever. You guys notice that? I'm actually having it act as if I'm using an if statement, but I don't have to because I'm just using Boolean. In this case, because all I want as an input is true or false anyway. As you get more complex, you're going to have to use some if statements to really do these, but you don't necessarily have to on the simple things, right? So if I run this, let's see if that worked out. Okay. All right, so I got to do my number between 1 and 10. I hit 4, that's true. Now it says type the number 4 or 8. I hit 7, it says false. That's not the number 4 or 8, right? All right, that's not. I could do it again if I wanted to. Obviously, if I built a loop here, I could do this again and again. I'm just going to do this for fun. Type the number 4 or 8. This time I'm going to hit 4, and now it says true, right? I don't have to have 4 and 8. Both conditions don't have to be met. Just one condition or the other condition have to be met in this case, okay? All right. Now, there's one more piece of logic we can use. By the way, in computers, in the actual circuitry, these are logic gates. Okay, that's the way these things work. All logic gates in a computer is built off of this and or and not functionality. If you get into actual like digital circuit design, you'll run into other things like the XOR, but it's really just a combination of and ors and nots together. It's still the same thing. Okay, so I don't know if you guys have looked at that aspect of computing before, but Boolean is what that's all based off of. All right, so let's do one more here, Z. And I'm going to do an input again, just for fun, right? I'm going to say type any number other than 13. You know, the exact way to get somebody to do something is what you want is to very specifically tell them what you don't want, right? So I'm telling the user of the computer, do not fix this here. Sorry. Do not type the number 13. Okay. Now I'm going to say for my print is I'm going to say not, it's like almost an if statement, not z equals 13. So really what that's saying is if I type in 13, it says 13 equals 13, but that's not the right answer, so it'll say false. So you can try this out here. Okay. So type any number other than 13. So if you type any number other than 13, this should give you a true, right? If you type the number 13, it should give you a false. Okay. So I'm basically saying I do not want 13, I do not want z to equal 13. Okay, that's false. And it's true if z does not equal 13. Okay, that's really what that's saying. Now I could just say print z exclamation equals 13, and that would work too. You could do that, but you'll see that that's not always what you want. So in this case, I'm using the not function. And you can run that and try it out. In fact, try it by typing in 13. False, right? 13. False. You should not have done that. Right. Run it again. 3, 8, true. 13. Any other number would work. 478. That's true. It's not 13. Okay. All right. So that's your basic Boolean stuff right there. You have your operators. We know they're a different class of data. They are bools. The answer is true or false for all of those. If you don't even have to use numbers at all, you can literally just say true or false with capital letter. And then down here, I'm just going to show you how we can use ands if we need both conditions to be met or multiple conditions. Guys, you can do multiple conditions. I could say, you know, and as many times as I need to in my program. But each time you do so, you do have to say x equals or some Boolean expression to that, okay? You cannot say x equals 1 and 10 and 14. You can't do that because it won't actually know what that means. You would have to say x equals 1 and x equals 2 and x equals 14, okay? So you've got to make sure you get that right. Notice that I put the y on either side of this or expression. Well, I've only got one thing on the not. Okay, so for the remainder of the class then,